personally, I like to say phonics had been my favorite topic from the JEE mathematics syllabus. So I hope you guys also enjoy conics as much, because conics is all about practice and how much can you remember. Like the some part of it comes through practice. If you like remember some formulas of it, so you can see the applications of these formula in your questions very easily. So yes, getting back to the context, we'll just see what the conics are, and we'll start with the first conic section that we have with us is the parabola. So let's start with the general brief of it. So let's see what does the first part say. So conic section or conic is a locus of a point which moves in a plane such that its distance from a fixed point is in constant ratio to its perpendicular distance from a fixed straight line. Okay, so this is very common. This is what you will observe while solving the whole conic section part of the J syllabus. That each conic, be it the parabola, be it the ellipse, be it the hyperbola, these all satisfy this definition to a certain extent. So what changes in the definition is the ratio. So basically, if the ratio is equal to 1, then the conic becomes, or the locus becomes that of a ellipse, or sorry, that of a parabola. If the ratio is less than 0, it becomes ellipse. If the ratio is greater than 0, it becomes a hyperbola. So it is very similar, and like it's very uh like related. All the conics are very related to each other. And also you will see a similarities in formulas as well to a certain extent. If you try to relate and imagine the formulas in your mind, you'll see that the formulas are also not that different. Okay, so now the fixed point is called the focus, the straight line is called the directrix, the constant ratio is called the eccentricity, the line passing through the focus and perpendicular to the directrix is called as the axis, the point of intersection of the conic with the axis is called the vertex. This is applicable to all the three conics that we are going to study, be it the hyperbola, the ellipse, or the parabola. We have already tried to cover ellipse in our previous lecture, so we'll be continuing with parabola here and see where it goes, right? So the sections on the right, circular cone by different phases. Okay. So see, one thing was very fast. I too was fascinated when I discovered this fact that why this whole part is called the conic section. Like why a parabola or a hyperbola or a ellipse is being called a conic. I didn't find any connections with a cone, right? But when you see a cone, and if you cut it from a certain angle or with a certain kind of angle or a certain kind of like intersection, be it the vertical or a horizontal, you see all the kind of ellipses, all the kind of conics or all the kind of locuses that we're talking about. If we cut it horizontally with the angle of 0 degrees, we get a circle. But if we increase the angle to a certain extent and make it less than 90 degree, we get an ellipse. But when we make it the angle as like more than 90 degree and equal to 90 degree, we get a hyperbola. But when we extend the angle above 90 degree, we get a parabola, right? So these are all the ellipse, like all the conic sections that you can see via a cone. Okay. So conic section is the locus of a point. So let's read what the definition says. If a point moves in a plane such that it distances from a fixed point, okay, this we already just saw the definition. And I stated this for you guys, right? That if it is equal to 1, we have a parabola, less than 1, a ellipse, greater than 1 is a hyperbola, and equal to 0 is a ellipse. Okay. So the generally, let's see, what do we have further? We have the focus. If the focus is alpha and beta and the directrix is this, the equation of the conic is given by this. Yes, this is a very important question. There are multiple instances that will be given certain focus and certain directrix, and it would be asked us to find out the equation of the conic, or it could be inverse, that the equation of the conic is given to us and we have to find the focus and the directrix. So we'll have to just apply the same equation and same kind of definition here. Okay, so now let's move on to the general equation of the conic. So what do we have here? If the general equation of the conic with the focus PQ and the directrix this is very easy. Can you tell me what are we doing here? We are basically taking out. See, this is the distance of x and y from P and Q, the square of it, right? And this is the perpendicular. And if we take this under the equation, the whole square equation of the line. So what do we get is perpendicular distance of x and y from this line. So it is basically what the definition we had started, that the distance from the focus equals to eccentricity into perpendicular distance from the line. This equation on simplify, okay, see, on simplification we get this, and there is a bunch of theory. I think you can read it for a minute. Basically, this generally represents a pair of equations is generated. Okay, okay. Yeah, this is can also be done. These are the conditions that can go through. Okay. Yes, this is also my suggestion to you guys. Always try to use geometry while solving. This is very helpful when you just apply geometry. It really like strongs and puts perspective, like it gives you a stronger perspective of solving the question. Where do you have to go through and how do you apply the equations and what part of the equation you might be lacking. Okay. So general equation of the parabola. Definition: parabola is the locus of a point which moves as that is equal to the distance of a baseline. Okay. So what do we have here is E is equals to 1. Okay. So moving on, the standard equation of a parabola. Just read it through. What do we have here? Okay. So you read it through. So the what do we have here is standard form of parabola is taken with the origin as the vertex and the focus lying on the x-axis. F be the focus and Zm be the directrix of the parabola and P be the point of the parabola. Then join Fp and P drawn Pm perpendicular to Zm. We get Fp is equals to Pm. Okay. To find the coordinates of the focus and the equation of the directrix, it's very easy to find out, guys. I think you can really do it very easily. We get this equation. It is the standard equation of the parabola. What is the standard equation? Y square is equals to 4ax. It is the standard equation of the parabola that is used. Okay, so let's see what do we have here, and we define the points for the standard parabola. Sorry, excuse me. Yes, so what do we have here? The focus becomes a comma 0. The directrix becomes minus a comma 0. The point of intersection between directrix and the axis is minus a comma 0. And the equation of the directrix is a is equals x is equals to minus a. Then we have the vertex at 0 comma 0. Then we have the axis as y is equals to 0, that is the x-axis. Then we have the lattice rectum, which is calculated as 4a. Okay, what else? So, okay, just let's go start with the basics and see. Find the equation of the parabola whose focus is 1 comma 1 and the tangent to the vertex is x plus y is equals to 1. Very easy question. Let's draw. X plus y1 is this, cutting at 0 comma 1, 1 comma 0, and we have here. So it could look like this, right? This would look like this, somewhat like this, right? So let's see. I have to find the okay. So the tangent of the vortex is okay. So okay, this is the tangent of the vortex. So it would look something like this. My bad. This would look something like this. Okay, so let's calculate. How do we calculate this? So if this is the tangent to the vortex, so we'll have to direct it somewhat like this. Okay, my bad. Directrix would look something like this. Let's calculate the distance between focus and the vertex. That is equals to a. So this should be also equal. So the distance between 1 comma 1 and the line is equals to, or it is equals to 1 by root 2. So I want the same here also. So let's see, the equation becomes, yeah, so the directrix is x plus y equals to 0. It is as simple as that, right? Mm, Yes, we get that. So we have the directrix for the focus. We can easily calculate the ellipse now. Sorry, the parabola now. Okay. Should we move on? Yes. Let's see another illustration. We have find the equation of the parabola whose focus is this, and the equation of the very easy question. SM is equals to PM, SP is equals to PM, very easy. Distance from the focus is equals to the perpendicular distance from the directrix. We'll solve and get answer. Very easy again, guys. Similar question. But my suggestion for you guys would be do not just simply see the solution and move on. I am doing this because I am in hopes that you guys have must done some kind of questions and we might have some better questions to do in the end. If not, we'll just revert back and do these questions otherwise. But I really don't want to waste my time on very easy questions. And but my suggestion for you guys would be you don't leave this question, right? You go like after this class, go and try doing these questions by yourself. That are you able to do them quickly or not? How much time is it taking for you to solve these questions? So try and solving them by your own as well once. Okay. So now getting back to the standard form of parabola. So you see what the standard form of parabola is? Y square is equals to 4ax, right? Then this is the right-handed parabola. Here a can be negative as well. If a is negative, then what do we get here is the left-handed parabola. Okay, now moving on. We have an upward parabola, we have a downward parabola. Okay. Okay, so let's just see what are the different forms that we have here. Let's see just to wait a minute. So you can read through it because this is the kind of diagrams that we have, and you can just simply see how these informations are related to each other. It's very simple, nothing out of the box. Okay, so you read through. So what do we see here is that here X and Y are completely replacing each other, and here X and Y are completely replacing each other, right? There is like a transformation if you observe it clearly, but there is an easy transformation of X and Y here. Okay, let's see another example. Reading the question, we have find the vertex and the axis, the focus. Okay, again, it is a very easy question. So I'll just hint you how do we do this. Since we have a variable of y and y square both, what do we do here is we try to complete the whole square of y. So what do we do? I'll just write it down. Wait a minute. Okay. So what do we do here is we try to make a whole square. So let's take 4 common, y square minus 5y. We get a 5 common. Oh God, this would make our life a bit troublesome, but let's see. Then we have to add 25 by 4 minus 25 plus 12x plus 67 is equal to 0. So you get what I did here. I tried to make it a complete square. So we get 4 into y minus 5 by 2 whole square. What is 67 minus 25? 42. So this is what are we left with. Yeah, very easy. You can check your answers from this. So did you check your answers? It's very simple. Okay, so let's move on. There is another question. We'll get back to this question later on because this has matrices application. So I really want to just go through the theory once and then see the illustration part. This as well. Okay, so let's see what do we have here. Okay, so this is another theory part of it. We'll get back to the illustration number 4, 5, and 6 later on. Let's see the parametric form first. So what does the parametric form say? So you guys understand, right, what a parameter is? So parameter by parametric form is what is the general form of equations that we take in. So for the standard parabola, that is the standard parabola, that is y square is equals to 4ac, we have a parametric defined. That is equals to at square, that is x is here the parametric forms are x is equals to at square and y is equals to 280. Okay, so if x is equals to 280 and y is equals, oh sorry, x is equals to 80 square and y is equals to 280, these are the parametric forms. So whenever someone says that we have to take a point on a parabola of a standard parabola, so what we can assume, that x is equals to 280 square and y is equals to 280. This is the assumption that we can always take. Okay, so now moving on. Point and parabola. A point and a parabola. That is also very easy. A point, this is very similar to what we did in for ellipse. So what do we do here is we put the, I think there is a network issue, there is a crack in voices. Okay. So what do we do here is, if the point x1 and y1 lies on or outside, what do we do is, we take this equation y square minus 4ac x is equal to 0 and see if this is less than 0, then it is inside. If it is equal to 0, then it is on the parabola. And if it's greater than 0, then it is outside the parabola. Okay. Find the set of find the set of values of alpha in the interval pi by 2 comma 3 pi by 2 for which the point does not lie outside the parabola. So does not lie outside means that is it is on the parabola or inside the parabola, that is less than equal to. So we simply put this point and put less than equal to sign and solve for alpha. Okay. Now moving on to the chord part of it. So you guys might be aware what a chord looks like. So a chord is basically connect a line connecting 2 points on the parabola itself. So basically there is a 1 point P which is equals to at1 square, and 281, and Q is equals to 81 whole square and 281. 28, sorry. So basically there are two parameters T1 and T2 and there are 2 points of parameter T1 and T2. So often we can also write, rather than writing P as A T1 whole square and 280, we can simply write P as T1 and Q of T2. What do we mean by T1 and T2? These are the 2 points of Q1 and Q. These are the 2 points with parameters T1 and T2. Okay, then the equation of point of the chord is, so what do we do? I prefer writing it as M of is equals to X plus A T1 and T2. Parabola pass to the focus, then T1 and T2 is equals to -1. Okay, this is a very important condition that you guys should remember. This is very often used in like questions. They would say that it is passing through parabola, so find the points. So we have to apply this condition that T1 and T2 is equals to -1. Okay. At one end of the focal chord of the parabola, y square is equals to 4ax. Okay, then the other coordinates would look like this. This is very important. This is also you must remember that if it is passing through parabola and 8 point, and if 1 point we are aware that it is equals to 80 square and 280, the other point would be q, and that would be a by t square and minus 2a by t. So moving on, what do we have? Now, moving on, what do we have here is the length. So how do we find the length of the chord? Be first easy part of finding out the length could be simply finding out the distance between these two of a focal chord, basically. Just a minute, guys. I'll be just getting a glass of water and come back. Yes. So getting back, what do we have? The length of the focal chord is equals to AT plus 1 by T whole square. Okay, so we know that t plus 1 by t is always greater than equal to 2 for all t not equal to 0. Then a into t plus 1 by t's whole square would always be greater than is equal to 4a. That is really easily to understand. Then pq is always greater than, sorry, I meant to circle it. Yes, so this is very important fact. The length of the smallest focal chord of the parabola is 4a, which is the length of its latus rectum. For this reason, the latus rectum of the parabola is also called the smallest focal chord. Okay. So the semilatus rectum of the parabola is the harmonic. This is also another fact. See, these are direct questions that are often practiced, but I am stating these questions for these theorems as like facts for you. So the second theorem that we have is of the harmonic mean, that the latus rectum is basically the harmonic mean between the segments of any focal chord of the parabola. So this is very important fact. So moving on, another fact, another theorem that we have is the circle described on any focal chord of the parabola as the diameter of that circle also touches the directrix. Yes, very interesting that if we have this kind of circle and this is the focal chord, so this would touch as its diameter, right? So this is the diameter. So it would touch the directrix as well. You get my point. Okay. So moving towards the next point, what do we have? The circle described on any focal chord of the parabola as diameter. Okay, this we already read through. Next point we have line y is equals to mx plus c meets the parabola at 2 points. That can be real, coincident, or imaginary according to greater than equal to okay. The condition for tangency is c is equals to a by m. Okay, understandable. The length of the chord, again, we can calculate. Yes, this is also a better interpretation. See, this is what I'm not saying you guys remember these, but the basic tangents and the basic formula of a chord you can easily remember, and that you'll remember only with practice. If you practice hard, you'll get the values out very quickly. Again, moving towards the next question, what do we have here is so again, moving towards the question, what do we have? That we have a quadrilateral ABCD and it is inscribed in y square is equals to 4x. Other three sides and three of its sides AB, BC, and CD pass through fixed points. This and show also pass through a fixed point. Okay. So consider four parametric coordinates, form the equations accordingly, and give conditions to the given conditions. Okay, so we have four parametric like coordinates T1, T2, T3, and T4. Equation of AB is y is equals to, of course, and then we have different equations. Okay, very easily we found that it's a fixed point. You guys can read through it, because basically they have done the solution for us. So we'll just read through and move on because I have to cover more points. Again, very basic question. You just have to find the relation. Moving on, these are a number of illustrations we have, but we'll try to skip them for a minute. If you guys want, I'll just put out the PDF link in the comments down, so you can easily get down the information on the PDF. So that would help you out. If you want to solve these questions by yourself, you can easily go through the PDF and find the questions. Okay. So now talking about the diameter of the parabola. So what does a diameter of a parabola look like? The diameter of a parabola is basically the locus of all the middle points of a system of parallel chords. Is called the diameter. Okay. So if there is a system of parallel chords, and if we connect the diameters by a single line, oh sorry, connect those points, the middle points by a single line, that line is called as the diameter, right? Okay, moving on. This is another question. Now get into tangents. Tangents are very fun. So equation of the tangent to any conic can be obtained by replacing x by x square. This is very important, guys. I'll like to is in highlight. I'll give you a minute to read it through. Like this can make your life so much easier. I'm telling you this part. Just read it through by yourself by a minute or two. You'll get it what and how important this equation is. Okay. So you read it. It is very easily understandable, and you can apply this on every conic, be it the parabola or the hyperbola or the ellipse. This is applicable on all these three of it. Okay, so moving on, we have okay, so let's just write the equations of tangent. So these are the equations of the tangents that we have. So they have applied the similar conditions that we studied, like stated here. Nothing new. When writing them in the parametric form is also very easy. You can simply replace the y1 x1 to the parametric forms here. Okay. So you understood that you simply replace the parametric uh, the the points x1 and y1 for a parametric form and get the equation in x and y. Okay, moving on. What do we have for slope? So this is the equations for slope. This some equation can also be written in parametric form, guys. So what we can do is here, you can simply derive it on your own. I'll say this is done in parametric, right? So yes, these are the three kinds of forms that you'll require for solving the equations whenever you have a tangent related question for parabola. And if you can remember these equations by heart, these do not require much of effort. These two are very easy to remember. Slope can be a bit tricky, but if you practice a bit, you will remember these. So if you remember these equations, there would be no question of yours that will be left unsolved, basically for parabola and tangents. You can easily solve these questions. Okay. So now moving on, the point of intersections. This is also an important point. Last point stated is very important. That the point of intersection of two tangents is equals to this. You get it? Okay, so now moving on to the director circle. So director circle is basically the point where perpendicular tangents meet. But here in the case of director circle, the director circle itself is the directrix. In the case of ellipse, you remember the director circle was something different, but here the director circle is different. Okay, moving on. So what do we have here is the next topic that we have is the pair of tangents. that when you see two tangents, okay. So we see that two tangents can be drawn from an external point of a parabola. The two tangents are real and distinct, or consonant or imaginary according to whether the points given lie outside, inside, or on the parabola. Okay, so the combined equation of the parabola looks like this. This is the standard form, guys. This is applicable on ellipse and parabola also. Okay, so this, yes, I was stating, this pair of tangents equation S1 is equals to T square is applicable on ellipse, hyperbola, and parabola both. Like all of these. So you can easily apply on all of these and get your answers out. Okay, so moving on to the chord of contact. So chord of contact, the chord of, basically know what chord is, right? If there's a parabola and there is 2 points, so when you connect these 2 points in the parabola, that becomes basically a chord. So chord joining 2 points of contact of two tangents drawn from external point P is known as the chord of contact of tangents. Okay, this is important. Okay, so this is very important equation and it's very easy to understand also. So what they're trying to do here is they have y x1 and they have replaced 4a x1 by 2, right? Okay. Common tangents to two conics. So okay, common tangent to two conics. In this section, we'll discuss some problems finding. Okay, this is the step-by-step equation. This is not completely required. This is something that you understand while solving questions. Okay, so let's see what do we have further. These are some point things that you can read and learn through because this is not something that you have to like keep them by heart. Okay, this is something that we should learn. This is a great concept and this is also important. What do we mean by pole and a polar? So let P be a point lying within or outside the parabola, given any straight line drawn through P intersects the parabola at Q and R. The locus of the point of intersection of the tangents to the parabola. Okay, let's see what they're trying to say. So basically, oh sorry, let me just use my pen. This is the parabola. This is the point P. So this intersects at Q and R. So the point of intersection of tangents. This point is called the polar to the given point P. Okay. Then the point P is called the pole. Okay, this is the pole and this is the polar. Okay, so this is the concept they're trying to say that if from a external point we just draw a line and it intersects the parabola at 2 points such that when we draw the lines of intersection, the tangents to these points, they intersect at the polar. Okay. Okay, so this is the polar of the point x with respect to the parabola is this. Okay. Let's move on to the normal. What does a normal look like? So normal is basically the line perpendicular to the tangent and passing to the point of contact of tangent and the parabola, right? So what do we have? See, we had see if they are perpendicular, then the slope of tangent and slope of normal's product would be equal to -1. This you can easily understand. So we'll try to apply this equation and solve the answer because we have a line of which we know the slope because we know the slope of the tangent. So we know the slope of the normal. We also know the point of contact. So it's very easy. If we know the point of contact and the slope of a line, so we can easily solve it, right? So we get the equation for the normal. You can see what are the equations. I'll give you a minute to read through it. Okay, so you must have read it through. Now we have the same, see, we have the tangents equation into multiple forms, right? So we have the normal equation also in the multiple forms. Moving on. Yeah, this is the equation. Okay. So if two parabolas have a common normal other than x-axis, then prove that B by, okay, this is very easy. Co-normal points. So what do you mean by co-normal points? Basically, three normals can be drawn from a point to a parabola. This is something that you have to understand. How do we prove that? So when do we write an equation? We have a equation of m cube. So that by that we understand that there are three slopes possible, and three slopes possible means that there are three lines. So what do we get to know? That there are three normals possible from that can be drawn from the parabola of three different slopes because there are three different lines. So we should also study the relation between the slopes and that we can easily understand what are the relations. This is something that you have to keep in mind that the sum is equals to 0, the product is equals to minus k by a, and their like the product by 2, like the when we multiply two numbers together and sum it up, we have minus a by 2a minus h by a. Okay, these are some useful results that you should read through. I'll not read it each and every one because it would take a lot of time and I have to like we'll have to hurry up a bit. Do we have any other topic missing? Yes. Subtangent and subnormal. So let the parabola, okay. I don't think this is very important. Yeah, this formula sheet is very important, guys. You have to learn this by heart, I must tell you. Not by heart, but this can be a reference point while solving. So try solving this once. And when you solve it, you'll be able to learn the formulas by yourself. So these are the definitions and the formulas that you have. Okay. So since we are done with the theory part of it, so let's do some questions if possible. We can do this question. This co-normal points we are not discussing because I don't seem to find them that important. So let's do this. Okay, there's a glitch, I suppose. No, there is not a glitch. It's not. So let's do some questions. Um, let's do this question. So what do we have here? There's a tangent to the parabola y square is equals to 8x. That makes an angle of 45 degrees with a straight line. Y is equals to 3x plus 5. Find the equation and its point of contact. Okay. So basically the slope is 3 here and the angle is 45. So how do we do this? The slope m2 minus m1 plus minus, of course, there is a plus minus always there. So what do we get? M1 plus minus M2 upon 1 minus plus M1, M2 should be equal to 1. So M plus minus 3 upon 1 minus plus M is equals to 3, I'm sorry, is equals to 1. So let us solve these equations. Minus 1 by 2 and minus 2. So this should be plus. There would be a mistake. I'm not going through this. But there are two kind of slopes that we have, that is minus 2 and 1 by 2. So we get the slopes. We can simply put the slopes in the equation and get the equation of the tangent. Okay. So moving on. I think we are done with this lecture. Also, I am having some issues with my throat, guys. So I'll have to like cut the lecture short. So if you have any doubts, I'll try to solve them in the comments. Kindly put any doubts you have in the comments. Otherwise, I am done with my theory. Also, I'll put up the link for this PDF in the comments so you can just see some of the questions with the solution. If there is any particular question that you would like to for me to solve, so I'll try to cover up in the future lecture if possible. But let's see. So let's just revise it up what we have done in the previous half an hour or so. So we tried to cover what are conics. So basically conics, as we had defined, are different profiles that we see when we cut or intersect a cone at different angles and at different surfaces. So this was our initial point. Then we started with parabola. So how did we define a conic cone? So first let's recap a bit. So conics are basically locus of points which have a fixed ratio of their distance from a fixed point upon the distance from perpendicular distance from a fixed line is constant for these guys. So that constant is called as the eccentricity, and when the eccentricity is equals to 1, it becomes a parabola. When it is less than 1, it has become in an ellipse. Greater than 1 becomes a hyperbola, and equal to 0 becomes a circle. Then we had different discussions over what kind of parabolas we have. These are the standard parabolas. Then we had the shifted parabolas. Then we had the inclined parabolas. Of course, then we moved on to tangent, I suppose. The point in parabola is easy. Then we had chord, then that we have tangents, pair of tangents, normals, and so. So I hope that clears everything for you guys. And these PDFs, guys, I would suggest you to create short notes while doing your mathematics revision, basically. This could really help you in the future. So let's wrap it up. If you have any doubts and suggestions for me, kindly you can just comment down and try to solve for you, solve the same for you guys. Okay, thank you.